Okay, previous week we have seen the field created by the line charge, infinite line charge. Okay. Mm, we have done one example, which I can remember. Okay. Um, so anyway, this is the resultant field created by a infinite line charge. Okay. We have to take the vector addition of each component. Okay, so we have to do integration because there are infinite number of point charges along the infinite length charge. Okay, so we have to get the resultant E field created by the line charge. Okay, so this is the final result. Okay, so we have to apply this one to solve the problem. Okay, so we will take another example. Okay, I have choose this one. Um, this 2.17 exercise given in our reference book. Okay. Um, so here it is said that there is a line charge defined by these two equations. Okay. These two equations, these are equations. Okay. These are line equations. Okay. So if I draw it, it is like this. So this is Z axis. This is Y axis. This is X axis. You have to use your uh, right hand to uh, to check the direction of this coordinates. Okay, so in Z direction, the unit vector we define as AZ. In Y direction, unit vector is defined as AY. In X direction, unit vector is defined as AX. Okay, so that is our usual notation. Okay, so now it said that there are two functions. Okay, that means that two function define the line charge. Okay, so here you should understand that uh, these are function. Okay, these are function. Okay, so this function define this line. Okay, line charge. Okay, so one function is y equal -2. Okay, this one like this. Okay, another function is z equal to 5. Sorry, y equal to, z is equal to 5. So this is this one, z equal to 5. Okay, another one is y equal to -2. That means this is the minus z direction, minus y direction. Okay, and -2 maybe here. Okay, so this is another line. Okay, these are two lines. Okay, so our unit charge is defined by this line. That means, okay, that means that line, this defined line. So this defined line is not go through this point. Okay, so uh, it is not said that this line is going through this point. Okay, so it is said that it is defined. That means so these are some points. No, these are some points in z and y plane. Okay, this is a point in z y plane. Okay, so if you move these points along the x-axis, x direction, x minus and x plus direction, you will get a line. Okay, so this line, so this is the line charge actually defined. Okay, so you should understand that one. Okay, so this is the line charge. Okay, this is the line charge. It is not going through these 2 points. Okay, so this line charge is defined by these 2 points. Okay, so that means in z axis. Okay, so this zy plane point is moving along Z axis, okay, Z direction, okay. So we will have a line charge like this with infinite length, okay, along the x-axis, okay. In other words, this line charge is parallel to x-axis, okay. So that is very important, okay. If you understand this scenario, then the solution is very easy, okay. So what we need to use that resultant line charge, that is this one, rho L 25 epsilon naught rho A, rho L 25 epsilon naught rho A rho, okay. So you have to use this equation to find E field at any point. Okay, so the point is given here. The point is this. This is the point. Okay, 1, 2, 3. Okay, okay. So this is the point 1, 2, 3. Okay, so x1, y2, x1, y2. Okay, then z3. Okay, so it is like this. So maybe a point maybe in this location. Okay, so that the point coordinate is 1, 2, 3. 1, 2, 3. Okay, okay. So now we need to find these parameters. Okay, so first we will find this parameter. This is rho. What is this rho? That is the perpendicular distance from this line charge to this point. Okay, perpendicular line charge to line charge from this point to from the line charge to this point. Okay, the perpendicular length, shortest length. Okay, so how we can find this length? Okay, so it is not much difficult. Okay, so here you should understand, as I told you, this line charge is going along the x-axis, not going along, going parallel to x-axis. Okay, so if you consider this point, okay, if you consider this point in z and y plane, this point coordinate is again 5 and 2. Okay, this point, so any point coordinate, any point in ZY plane, that is in ZY plane, I will write it here, in ZY plane, okay, in ZY plane, okay, so in ZY plane, any point on the line charge, any point of the line charge is defined by y equal minus 2 and z5. Okay, y minus 2 and z5. Because in ZY plane, this line is going through these 2 points. Okay, not going through this point. This point is, any point is defined by these 2 coordinates. Okay, minus 2 and minus 5. So this one you should understand. Okay, this one you should understand. So try to think in 3 dimension. Okay, so then you can understand it very well. Okay. So it is hard to draw the pictures in 3 dimension. Okay, so if you have any problem, you can come and meet me. Okay, then I can explain this. Okay, so this is that. Okay, in ZY plane, this point is also y minus 2 to Z5. Okay, so this line is parallel to x-axis. This line is parallel to x-axis. So we can neglect the x x coordinate. Okay, I have explained it in previous week, as I can remember. Okay, because if you consider any point, if you consider any point, that point uh, has a uh, constant length from this line charge to x-axis. Okay, so you can ignore this x-axis coordinate. Okay, uh, so uh, so now you can think two-dimensionally. Now you can think two-dimensionally. Okay, so if I write like this, okay, this is z and y axis. So this is zy plane. Okay, this is zy plane. Okay, so any point, so line charge point in zy uh, zy plane is this one. Okay, so that is p uh, y is -2, z is 5, -2 to 5. Okay, so this is the this is the point of the line charge. Okay, now you need to find zy plane. Okay, zy plane, that point is 2 to 3, no, 2 to 3. So this is p point, 2 to 3. Okay, now the rho is the distance between these 2 points. Okay, so if the x, so we know that x-axis, so we know that x-axis coordinate is there. Okay, so x-axis coordinate is 1 actually. Okay, x-axis coordinate is 1. So this point is come here, and that point is 1. Okay, so x-axis coordinate is 1 to this point, and this also x-axis coordinate is 1. Okay, so you can take this point in x-axis coordinate 1. Okay, okay, so same point. Okay, this point you choose a point. Okay, so maybe you can understand this easily. Okay, so the choose point. Okay, you choose a point, you should choose a point uh, you should you should point, you should choose a point at the line charge uh, at x is equal to 1. Okay, so that line charge may be 1, uh, that point will be 1 -2 5. This is the zy coordinate, -2 and 5. Okay, so you choose that point when the x-axis is equal to 1, x coordinate is equal to 1. Okay, in the same manner, you should choose a point, you should choose the point. Okay, at so given point is, that is not the choose point. Okay, given point is uh that is p 1 2 3. Okay, so you choose that point, you choose this line points, the point at the charge, point at the line charge, that is equal to x equal 1 coordinate. Okay, so that is what you have done. Okay, so now you can see that. Okay, so when you are calculating 1 minus 1, it will be 0. Okay, so in this way also you can try to understand, or maybe you can use this two-dimensional picture, maybe. Okay, anyway, you should understand this. Okay, so here the row distance, that is the distance, this is the row. Okay, from this point to this point. Okay, so you can use the Pythagoras theorem. Okay, so if I use it, 1 minus 1 is square, that is x-axis is square, sorry, x coordinate. Then -2, that is 4 is square, that is y-axis coordinate, plus 5 minus 3 is square, that is z-axis coordinate. Okay, so maybe you can ignore this one, or maybe you can count this. Okay, so anyway, the answer will be correct. Okay, so this row will be the row, the length of the row, length of this the magnitude of this length will be rho, and it will be uh, 4 is square 16. Here 2 is square 4, that is means 20 square root. Okay, so this is the distance, that is the rho. square root 20. Okay, I hope you understand it. Okay, මේක dimension 2 dimension විදියට හිතුවත් කමන්නේ 3 dimensional විදියට හිතුවත් කමන්නේ. හරි. එතකොට මේක line charge එක infinite lane line charge එක. හරි. එතකොට ඒක තියෙන්නේ x axis එකේ. හරි. එතකොට x axis එකේ ඕනම point එකක් ඔය කට්ටියන ඕන වෙලාවකට select කරගන්න පුළුවන්. එතකොට අපිට දීලා තියෙන point එක 1 2 3. ඒ කියන්නේ x axis coordinate එක 1. හරි. එතකොට අපි තෝරගන්න line charge එකේ point එකත් x axis එක 1 වෙන්න ඕනේ. එතකොට තමයි perpendicular distance එක එන්නේ. හරි. එතකොට එයා 1 තෝරගත්තොත් එතකොට අපි ZY plane එකේ ඒ coordinate එක එන්නේ 2 3. Okay. ඔය කට්ටියට 1 කියන එක consider කරන්නත් පුළුවන්. ඕනනම් මෙතන ZY plane එක consider කරන්නත් පුළුවන්. හරි. එතකොට අපි coordinate තුනම දාලා Pythagoras theorem එක දැම්මොත් අපිට එන්නේ මේ විදිහට 1 1 -2 x coordinate එකේ අඩු කරලා ස්ක්වයර් එක y coordinate දෙක අඩු කරලා ස්ක්වයර් එක z coordinate දෙක අඩු කරලා එන ස්ක්වයර් එක. හරි. එතකොට මෙතන automatically මෙතන x coordinate එක බිඳුව වෙනවා. හරි. x length එක බිඳුව වෙනවා. හරි. මොකද ඔය කට්ටිය එකම x coordinate එක තමයි choose කරන්නේ. Okay, so we will get this row as square root 20. Okay, then we need to find the row L is given. Okay, row L is given. So this is that is the line charge density. Okay, so that is this one. Okay, row L, and also you need to find this one, arrow. Okay, so what is arrow direction? Arrow direction is like this. Arrow direction is in this direction. Arrow. Okay, so this is this direction. Okay, so you need to find this direction. So you have to use the vector addition, vector addition theory, no? So that will be easy. Okay, so again you can see that. Okay, again you can see that. Okay, so this actually this okay, so this direction is in ZY plane because it is parallel to x-axis. Okay, perpendicular to x-axis. Okay, because this line charge is parallel to x-axis. Okay, so so this direction is parallel to this line charge. That means it is sorry. This direction is perpendicular to this line charge. That means it is perpendicular to x-axis. Okay, x direction also. Okay, so this direction is in ZY plane. Okay, so very easily you can find this this vector. Okay, so here this is the arrow direction. Okay, arrow direction. Okay, now this is row. Okay, so this direction. Okay, so we have one vector here and one vector here. Okay, so this vector, one vector here and this vector here. Okay, so this vector, for this vector, y is -2 and x z is 5. Okay, so this vector will be, okay, this vector will be -2, that is in y direction, ay plus 5 in z direction, that means az. Okay, and if you consider this one, this direction, that is 2 in y direction. That means if I consider this one, that is 2 in y direction, ay minus, sorry, plus 3 in z direction, 3 in z direction, az. Okay, so this is so here this vector, this is this vector, and this is this vector. Okay. So our row vector, okay, so you can use vector addition. Okay, so this vector plus this vector is equal to this vector. Okay, so I will write this vector as maybe AP or something, and this vector as AQ. Okay, so then AP plus a row, sorry, this vector I will write as P, and this vector as Q. Okay, so P plus rho equal Q. Okay, so rho is equal to Q minus P. Okay, so we know this Q vector. Q vector is this one. This is the Q vector. So that is AY plus 2AY plus 3AZ. Okay, so that is 2AY plus 3AZ minus P vector. So that is minus 2AY. So minus minus it will be plus 2AY plus 5AZ. Okay. So the rho is nothing but the addition of these vectors. Okay. Algebraic addition of these vectors. Okay. So it will be 2 to 4AY plus 3, 5, 8AY. Okay. 8AZ. Okay. So this is the row vector. Okay, this is the row vector. Okay, so you need to find a row. That is the unit vector you need to find. You need to find the unit vector. Okay, how to find the unit vector? The row vector divided by the magnitude of this row vector, you will get the unit vector a row. So you know row vector, that is 4AY plus 8 8 AZ divided by magnitude is square root 20. Square root 20. Okay. So this is a row. Then you find all the values E. Row L is given. You can substitute that value here. 4, 5 epsilon naught is also given. You can epsilon actually. This is it should be epsilon. Okay, but here it is given that epsilon is equal to epsilon naught. Okay, so you can put epsilon naught here. Okay, then rho is square root 20, then a row is 4AY plus 8AZ square root 20. Okay, so this is the final answer. You can simplify this using a calculator. Okay, so your field, E field, is a vector that is in YZ plane. That is correct, no? Because the line charge is parallel to the x-axis. Okay, so your vector, your E field vector should be in ZY plane. ZY plane. Okay, so your answer is correct. We can guess that our answer is correct. Okay, okay. So that is that.